let's see how you can change the classifier model that you use in Wekinator and how that affects the resulting models that you build. The best place to explore this is using the Classifier Explorer in the Wekinator examples, teaching examples folder. So that's what I'll open here, and that's a processing sketch. So here's the Classifier Explorer. The way this works is that it's a 2-input model, so run with 2 inputs, 1 classifier output, so this should be getting familiar by now. Change the inputs to 2, change the output to 1, and this is a classifier, so 5 classes is perfectly fine. We'll get that started. You can see ask out, ask in. Let's double check and make sure that we're receiving, and let's check that we can build a model using this. So here we go. The model I'm going to use is this sort of edge of the screen, left, right, and center model. So to use the Classifier Explorer, you can press the number key to change what class you're labeling, and then you can train all from the Classifier Explorer window here. So I'm going to call class 1 this edge of the screen type model. Okay, so that's sort of the edges, like our edge of the stage. Class 2 is this sort of left side of the screen. Class 3 is the center, and class 4 is the right side. And I don't know, let's give that a chance. We'll see what that looks like. Train on these examples, and now it's trained. And then if I click this sort of toggle switch, I can switch to run. So a nice way, and then when I click here, it'll classify each point that I click on. So this is in the blue category, this is in the green category, this is in the red category, and a good way to see the whole space here is to look and draw these decision boundaries over here. So that'll show you how this thing is thinking about this. You can see, yeah, this is not bad. It's sort of doing what I want. There's this spot here, right? This I would classify as the edge. And similarly over here, so I would maybe add some points over here so I can go back to record, and I'm going to switch to class 1 and add some additional points so that you can sort of double check that those are doing what they want. And I'll add a couple points in here as well for class 2, and add a few for class 4 as well. And now let's train on these examples, go to run, clear the test examples, and then draw the decision boundaries again. And this is doing a better job. There's still maybe a little bit of an issue right here where maybe this should be red in there, but this is doing a pretty good job of classifying things sort of how I want. But we can sort of see how that changes as we use different models. So how to change the model comes in here. I click this little draw icon and use that to edit. I can change the name. The key thing I want to do now is change the model. So the model type right now is K nearest neighbor. That's that first model that we looked at. So one thing we can do is go from the K nearest neighbors. Instead of using the 1 nearest neighbor, we could use the 3 nearest neighbors. So that is going to look at the 3 closest points, and whichever has the most of the 3 closest is what it will classify it as. So for 3 closest, let's look at how that changes things. So here's my initial classifier. I'm just going to copy what this looks like so we can refer back to it later. Now using the exact same data, I can clear these test examples, train again, and draw the decision boundaries again. You can see I get some pretty different results here, because you can see in the case of the green here, my class 3, that's now no longer showing up as a class at all, because for no point here are there of the majority of points of class green closest to it. So even right on this green point, there's going to be, in this case it looks like 2 blue points that are the closest of the 3 closest points. There's 1 yellow point that's close, and then 2 blue points here that are close, and so this gets categorized as blue. This would be a good type of model if you had, say, some like noise in your training examples. So there are some points in there where they're in the wrong spot. So let's say that if we went in here in the training and changed the training examples, so that let's say we had a few more green points, but we just accidentally clicked green over here, and just accidentally misclassified things. Now, if I train there and draw the decision boundaries, now I get something that looks much more reasonable. These few points that are, what do you call them, outliers or noise or misclassified, these few points or mislabeled, these few points don't affect our results, so that's sort of nice. Again, it really depends on what you're trying to do, which model is going to be best. You might want to test out several of these. The last one I'm going to show is this decision tree. So this we can go into model type k-nearest neighbors. You can see we have a whole bunch of different kinds of models. 5 that are sort of good choices, and k-nearest neighbors we can actually change the number of neighbors we use. Add a boost is another really interesting and good model. I'll use just that normal decision tree. Add a boost though is one you should definitely play around with. Decision tree J48. Try that. This is that decision tree that we looked at. So I'll clear my test examples, retrain, and draw the decision boundaries. You can see, whoa, that's pretty weird looking, right? So here, that decision tree is doing a pretty, you could say it's doing a pretty bad job, right? It's just making decisions based on, doing a tree, saying, okay, is this greater than or less than some value? In this case, this is really probably not what we want at all. So for your own classifiers, you should be able to go in and change the model that you're using to see, which one gives you the best results for your classifier.